Today the topic for discussion is fundamental theorem on differences of polynomial and missing terms. These two topics from the chapter interpolation. So theorem is if fx is the nth degree polynomial in x, then prove that the nth difference of fx is constant and delta raised to n plus 1 fx and all higher differences are 0. That is, if you find delta raised to n fx of this fx polynomial of degree n, then it is constant. It is not function of x. So I have to show this. And the further differences of fx are 0. Obviously, if the nth difference is constant, then n plus 1th difference and all the further differences, higher order differences are obviously 0 because the delta of constant is 0. So first we have to show the nth order difference of fx is constant. So first take fx as a nth degree polynomial in x. Suppose this is the polynomial of degree n, a0 plus a1x plus a2x square plus an x raised to n. This is the general polynomial of degree n, where a0, a1, a2, an are obviously constants. Okay, and n is positive integer. Obviously, the power degree of the polynomial is positive. Okay, so this a0, a1, a2, an are constants. Then we have to find the delta raised to n of fx. So how we can find delta raised to n fx? First find delta fx, then delta square fx, delta cube fx, and then generalize the result. We have the delta raised to n fx. So first we will find delta fx. What is delta fx? Is f of x plus h minus fx. This is the definition of delta fx, forward difference operator. And what is f of x plus h? F of x plus h is what? This is fx. So f of x plus h is what? Replace as x by x plus h in this. So this is the f of x plus h, this bracket. What is a0 plus a1 x plus h, a2 x plus h square, an x plus h raised to n. This is f of x plus h. Minus fx means this is as it is in the second bracket because there is negative sign. So right bracket. So then what is the simplification? a0 minus a0 is 0. Then a1x and this plus a1x and this negative a1x. Because of this negative, all the terms in the bracket are negative. So a1x minus a1x is 0. And then what do we have? a1h is the first term. Okay. And then a2x plus h bracket square. So what is this term? a2 and this term a2x square. Take a2 as a common factor. What do we have? X plus h bracket square minus x square in the bracket. Similarly, the next term is what? a3x plus h bracket cube, and here is a3x cube. So take a3 as common. So what do we have in bracket? X plus h bracket cube minus x cube. Similarly, the last term, this take this an as common factor plus so on, an x plus h raised to n minus x raised to n. Then simplify all these brackets. So next term, next step is what? a1h as it is plus a2, and the square of this bracket is what? X square. First term is x square, and this x square minus x square become 0, and then twice hx plus h square, this bracket, simplification of this bracket. Similarly, simplification of this bracket, take x plus h bracket cube is x cube get cancelled, so remaining terms are in this bracket. 3x square h plus 3x h square plus h cube, x cube and x cube plus x cube and minus x cube become 0. Similarly, this an, the expansion of this x plus h raised to n by using binomial theorem is what? The first term is x raised to n, and that x raised to n minus x raised to n becomes 0, and the next term is what? N x raised to n minus 1, this term into h. The next term is what? N minus 1 by 2 factorial x raised to n minus 2 h square. The power of x reduced by 1, and the power of h increased by 1. Here is h, here is h square. What is the next term? Yeah, n minus 1, n minus 2 by 3 factorial x raised to n minus 3 h cube. But no need of writing that term. And the last term is what? H raised to n. So this is the expansion of this bracket by using binomial theorem. Okay, and then add the constant terms, add the terms of x, add the terms of x square, and all the remaining terms. So what is the addition of all constant term? Is b1. What is the addition of all terms of x? b2x, where obviously b2 is what? Is the addition of coefficients of all x terms in this step. Okay, and is denoted by b2. b2 is obviously constant. Similarly, the addition of all the terms of the degree 2, and that is equal to b3x square. In this way, this is the single term, that x raised to n minus 1. What is its coefficient? n h n h. Okay, x raised to n minus 1. So addition and addition of all these terms, and obviously this b1, b2, all these b3, b4 are constants coefficients. So this is delta fx. So observe this delta fx. This is again the polynomial in x of degree n minus 1. Fx is a polynomial of degree n. Delta fx is a polynomial of degree n minus 1. That is, the degree of the polynomial is reduced by 1. So similarly, if you find delta square fx, then it is a polynomial of degree n minus 2. In this way, delta cube fx is polynomial of degree n minus 3. In this way, we have to find the delta raised to n fx. So next step, what is the delta square fx? Delta square fx is delta of delta fx. That is, delta of this is delta square fx. So now we will find the delta square fx. What we have to show? What we have to find? We have to find delta raised to n fx. So how we can find delta raised to n fx? First find delta fx, then delta square fx, delta cube fx, and then write delta raised to n fx. So this is delta fx. Now this is the polynomial of degree n minus 1. Now in next step, we will find delta square fx. So this is the second step. This is the expansion. This is the description. What is that? This is the polynomial of degree n minus 1. That is, the degree of delta fx is reduced or less than the degree of 1 less than the degree of fx. So no need of writing these statements. Directly find after delta fx, find delta square fx. So what is delta square fx? Is delta of fx, and delta fx is what? F of x plus h minus fx. So after multiplying delta, we have this, and then delta f of x plus h. So we can write delta f of x plus h. So this is delta fx. So what is delta f of x plus h? Replace x by x plus h. So b1, b2 x plus h, b3 x plus h bracket square, n h x plus h raised to n minus 1. Delta f of x plus h. So this is b1 plus b2 x plus h, b3 x plus h square dash 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 so on, plus n h x plus h raised to n minus 1. This is delta f of x plus h, minus delta fx is what? This, by using the previous equation. Okay, so this is b1 plus b2 h n x raised to n minus 1. Then what is the calculation? b1 minus this b1 becomes 0. Then this b2x minus b2x, this negative sign, effect of this negative sign, minus b2x becomes 0. And then terms is what? b2h is the first term, b2h. So what do we have? PowerPoint not supporting properly. That's why this break. Okay, now supporting. So what do we have? We have, this is what? This is what? Delta fx, and this is delta f of x plus h. Then simplification. So b2x and b2x become 0, and then b2h is the first term. Then b3, take this b3 and this term b3x square. So take this b3 as common. So what do we have in bracket? X plus h bracket square minus x square. In this way, this term n h a n. Here observe n h a n. Take this n h a n as common factor, and what do we have in bracket? X plus h raised to n minus 1 minus this negative side, because of this negative side, minus x raised to n minus 1 in bracket. Okay, so what do we have? The next step, b2h as it is plus b3, and the simplification of this bracket is what? X plus h bracket square is x square, and this minus x square becomes 0. Then what do we have? Twice hx plus h square. In this way, the simplification of this bracket plus so on, h raised to right, this h raised to n minus 2. This is not here the term, plus this plus so on, right? Plus so on. Ignore this h raised to n minus 2. Ignore this. So plus so on. What is the n h a n, and the simplification of this bracket is what? The first term is x raised to n minus 1, and this x raised to n minus 1 becomes 0. Then next term is x raised to n minus 2. Its coefficient is n minus 1. X raised to n minus 2 into h. This is by using binomial theorem, expansion of x plus h raised to n minus 1. Plus so on, last term is what? H raised to n minus 1. So this is the expansion of this term. Expansion of this term. Okay. Okay. We have this n minus 1 x raised to n minus 2, the second term of this expansion, because the first term is x raised to n minus 1 and minus x raised to n minus 1 becomes 0. The second term is what? X raised to n minus 2. Its coefficient is n minus 1, because power is n minus 1 into h. And the last term is what? H raised to n minus 1. So this is the expansion of this bracket, simplification of this bracket. Okay. After cancelling x raised to n minus 1, x raised to n minus 1. And again, adding and subtracting the similar terms, that is constant terms, terms of x square. We have this c2 plus c3x plus c4x square. These are the notations for the coefficients of constant coefficient of x square. Similarly, all remaining terms. And this is the single term, x raised to n minus 2. And what is its coefficient? n minus 1 into h square an. This is an x raised to n minus 2. So after simplification, that is adding the similar terms, we have this. This c2, c3, c4 all are the constants. Okay. And if we observe again, the delta square fx is what? Is again a polynomial in x, but is of degree n minus 2. Delta fx is polynomial of degree n minus 1. Del fx is polynomial of degree n. So what is delta square fx? Is polynomial of degree n minus 2. Similarly, to find delta cube fx, then it is a polynomial in x of degree n minus 3, and so on. So continuing this process, what do we have? The delta raised to n fx is what? Is this, that n minus 1, n minus 2, n minus 3 up to what is the last term? 1. 1 is the last term. What is the coefficient last term of delta square? Is n minus 1, that is reduced by 1. So if we find delta raised to n, what is the last term? n minus 1, that is 1. And the previous term is 2. That is this n minus 1, n minus 2 goes up to 1. And that is n factorial. H raised to n, an, x raised to, what is the coefficient of x? What is the power of x? Here is delta square. So what is x raised to n minus 2? What is the power of x? Delta square is there. Therefore, the x raised to n minus 2. Similarly, what is the last term of delta of fx? Is x raised to n minus 1. So what is the power of x? X in delta raised to n is x raised to n minus n. Here is n minus 2 because it is delta square. So here is delta raised to n. So x raised to n minus n, and x raised to n minus n is 0, x raised to 0, that is 1. And therefore delta raised to n fx is what? N factorial h raised to n a n. This is n factorial. So what is delta raised to n fx is constant. So this is the first part of the theorem, that the nth difference of fx is constant. That is the first statement. This prove that nth difference of fx is constant. And then we have to show the n plus 1th difference and higher differences are 0. So this is constant, and therefore delta raised to n plus 1 fx is 0, because delta of this is 0. Delta of constant is 0. And so all the further differences are 0. Delta raised to n plus k, fx is equal to 0 for all k greater than or equal to 1. Because we have delta raised to n fx is a constant term, and therefore all the further differences are 0, because the delta of constant is 0. So hence the proof of the theorem. Next is some problem on the determination of missing terms. So the first problem is estimate the missing term. So here is the missing term, this question mark. So one term is missing. In the next problem, we will see the two term missing problem. So here is one term missing problem. So where to find the value of value corresponding to 4? The table is given. These are the values of x. These are the values of y or fx, and we have to find these terms corresponding to 4. So here, how many values are given of y? 1, 2, 3. This is not given. 4, 5, 6. So first sentence is 6 values are known, or 6 values are given, and therefore the 6th order differences being 0. Because we know that if we find the forward difference table, then we observe that if there are 6 values, then the last column of the table is what? Is delta raised to 5 fx is the last column. If the 6 values are given, then what is the last column of forward difference table? It is delta raised to 5 fx, and all the further differences are 0. That is, if the 6 values are given, then delta raised to 6 fx is equal to 0 for all x. And then substitute delta. So the first sentence is what? 6 values are given, and therefore delta raised to 6 fx is equal to 0. This is observed in what? This is observed in preparing forward difference table. If you prepare forward difference table with 6 values of x and y, then table terminated at delta raised to 5 fx. That is, what is the next order difference? 6th order difference, 7th order difference, all are 0. So 6 values are given, and therefore delta raised to 6 fx is equal to 0. This is the first step. Then write delta as e minus 1, because e is what? 1 plus delta. What is the relation between e and delta? E is 1 plus delta. That is, delta is e minus 1. And then its 6th power by using binomial theorem. These are the 7 terms. The 6th power of this what? E minus 1 contains 7 terms. And this is by using binomial theorem. And there is minus sign. So write the first term plus, then minus, plus, minus, plus, minus, plus, minus. If there is a plus sign between these two terms, then write all terms are positive. But there is negative sign, so write first term plus, then minus, plus, minus. And what are the powers of e? Starting from e raised to 6 and ending at e raised to 0. And what are the powers of 1? Starting from 1 power and then increase the power by 1. But any power of 1 is equal to 1, and that's why. So what is the term first? E raised to 6 minus the next term is what? 6c0, 6c1 e raised to 5, and 6c1 is 6. Then 6c2 is 15 e raised to 4. So 1 power of e decreased by 1. Similarly, then 6C4, 6C5, 6C6, and 6C6 is 1. Okay, so this is the expansion of E minus 1. This expansion is by using binomial theorem into fx is equal to 0. So multiply by fx in bracket. So we have e raised to 6 fx and all these terms. And then what is e raised to 6 fx? Shift the point to 6 points next. So what is e of fx is f of x plus h. Here h is 1 because if we observe the values of x, then what are the difference is 1. 1, 2, 3, 4, 5. Difference is 1. Value of h is 1. So what is e raised to 6 fx? Actually, e raised to n fx is f of x plus nh. And so e raised to 6 fx is f of x plus 6h. But h is 1. So shift the point to 6 points next. 6 points. And therefore, we have this. Then e raised to 5 fx is f of x plus 5. E raised to 4 fx, e cube fx, e square fx, e fx is f of x plus 1 and fx. Okay. Then take h, taking h as 1, obviously. Then put x is equal to 0. So what is the substitution of x? Observe this. The value of x is what? Is starting from 1. So substitute x is equal to 1. Here is x, the first value of x is 1. So substitute x is equal to 1. Don't write here x is equal to 0. Put x is equal to 1, not x is equal to 0. So put x is equal to 1. And then what we have? We have the first value f of 7. F of 7. Previous value f of 7. Here is f of 7. So f of 7 is 128. So here put x is equal to 1. Here is a mistake that x is equal to 0. So put x is equal to 1. And then what do we have? F of 7, f plus minus is minus 6, f of 6, and all the terms. That is, put x is equal to 1 in this. And substitute all the values. That is, substitute the value of f of 7. What is f of 7? What is f of 7? F of 7 is 128, f of 6 is 64, y or fx. Then f of 5 is 32, and we have to find f of 4. So remain f of 4 as it is. Then write f of 3, f of 2, f of 1. Okay. So substitute all the values and calculate. We have the f of 4. So here is a mistake that this is not 3, this is f of 4. So calculate. So put from this, instead of this writing, solve this example by substituting x is equal to 1 in this. Okay, and calculate the remaining calculation. We get f of 4. Next problem of missing terms. Estimate. So estimate the production for year 1964 and 1966 from the given data. Okay, that is, the two terms are missing. These two terms are missing. 1984 and 1966. Okay, so year and the production. That is we consider this row as x, values of x, and the second row is the value of fx. So here 5 values are given: 1, 2, 3, 4, and 5. So first statement is what? 5 values are given, and therefore delta raised to 5 fx is equal to 0. Therefore delta raised to 5 fx is 0. The first sentence is important. That 5 values are given: 1, 2, 3, 4, and 5. Two values are missing. So 5 values are given, and therefore delta raised to 5 fx is equal to 0. Write delta. Delta is e minus 1 because e is 1 plus delta. And then e minus 1 raised to 5 is what? Expansion is this, that 6 terms. Then multiply by fx, we have this step. And then e raised to 5 fx is f of x plus 5. E raised to 4 fx is what? F of x plus 4, by using the definition of e, that is the shift operator. And put x is equal to 0. Here is put x is equal to 1961. Here is a mistake, that f is equal to don't write here x is equal to 0. Substitute x is equal to 1961. So write here 1961. And then what we have? 1961 plus 5. 1961 plus 5, that is 1966, and all the remaining terms. So put the value of x is equal to 1961. Then we have the equation. 1961 plus 5 means 1966, and all the remaining terms, 1965 and all the remaining terms. Similarly, substitute x, and that is the equation 1. Simplify that equation and write that is the equation number 1. Then substitute x is equal to 1962, and simplify, and that is the equation number 2. And solving these two equations for f of 1966 and f of 1984, and we get the values. So obtain two equations from this. Obtain two equations. How we can obtain two equations? By substituting first x is equal to 1961, we get one equation, and by substituting x is equal to 1962, we get a second equation. And in that two equations, the values of f of the value of f of 1966, suppose this is f of 1984 is suppose a, and suppose write 1966 as a value b, small b, and then solve that two simultaneous equations for a and b, and find the values of 1984 and 1966 corresponding values. Okay, so these are some problems to solve you. These again, they are the two terms are missing, and here is only one term missing. Here again two terms are missing. Here is one term is missing, and their answers are given below. The answer of last question is 369. Okay, so how we can obtain the two missing terms? That here 1, 2, 3, 4, 5, 6 values are given, and therefore delta raised to 6 fx is equal to 0, right? That delta is e minus 1 raised to 6, find its 6th power, and then substitute x is equal to 1, we get one equation. Substitute x is equal to 2, we get another equation. And suppose the value corresponding to 3, that is suppose f of 3 is a and f of 5 is b, and then write solve the equations 1 and 2 for small a and small b. Okay, similarly here only substitute x is equal to 0 in the equation. 1, 2, 3, 4 values are given, and therefore delta raised to 4 fx is equal to 0, and substitute x is equal to 0 in that equation after simplifying. Okay, so if the two values are missing, then substitute x is equal to first value and x is equal to second value. We get two equations, and solving after that two equations, we get the two missing terms. Okay, so we'll stop here. Solve the exercise of missing terms and send me on the WhatsApp group.